Hello friends, welcome to the class. Today we will solve the problems of inverse trigonometry exercise 2.2. Okay, so the first question is prove the following. Okay, the first question is 3 sine inverse x is equal to sine inverse 3x minus 4x cube, where x belongs to minus 1 by 2 to 1 by 2. Okay, now when we look closely, we can see that this expression resembles to some trigonometric formula. Okay, we'll see that. So we'll take the right hand side and prove. Okay, so we'll take the right hand side, RHS, that is sine inverse 3x minus 4x cube. Okay, now see, if you see here, this resembles a trigonometric formula, that is sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. Okay, this is the formula. Now if you take the value of x sine theta, we'll see it. Okay, so let's take x is equal to, let x is equal to sine theta. So we get sine inverse 3 into sine theta minus 4 sine cube theta. Okay, now this can be written as sine 3 theta. So sine inverse sine 3 theta. Okay, now again, when you look closely, you will see that this resembles to a property in the inverse trigonometry, that is sine inverse sine x is equal to x, condition if x belongs to minus pi by 2 to pi by 2, the range of the sine inverse. Okay, this is the property. Sine inverse sine x or sine inverse sine theta is equal to theta, anything else. Sine inverse sine x is equal to x if this x belongs to the range of the sine inverse. We'll see whether this belongs to that. Okay, so we can write this as sine inverse sine 3 theta is equal to 3 theta if, again, if the condition is if this theta belongs to, sorry, not if 3 theta belongs to minus pi by 2 to pi by 2. Okay, sine inverse sine 3 theta will be 3 theta only if this 3 theta belongs to this range of the sine inverse. Okay, now we'll verify that. Now here we have already been given the condition x is equal to minus, x belongs to minus 1 by 2 to 1 by 2. So we'll take that x belongs to minus 1 by 2 to 1 by 2, close interval. We can write this as x minus 1 by 2 less than equal to x less than equal to 1 by 2. Okay, now we have taken x is equal to sine theta. We have taken x is equal to sine theta. So let's put sine theta here. Okay, minus 1 by 2 less than equal to sine theta less than equal to 1 by 2. Okay, now since x is equal to sine theta, we can write theta is equal to sine inverse x. So we can change this expression as, we can take theta. Okay, we can change this as sine inverse minus 1 by 2 less than equal to theta. Okay, less than equal to sine inverse 1 by 2. Okay, now you know that sine inverse 1 by 2 is pi by 6. Okay, so we can write this as minus pi by 6 less than equal to theta less than equal to positive pi by 6. In the ratio table, if you see sine 30 degrees 1 by 2, that is sine pi by 6 is 1 by 2. So sine inverse 1 by 2 can be changed as pi by 6. Okay, now here we have sine inverse sine 3 theta is equal to 3 theta. We have to check 3 theta whether it lies in this range. So let's multiply this with 3. 3 theta now less than equal to minus pi by 6. Here also we multiply with 3 less than equal to 3 multiplied pi by 6. So 3 2's and here 3 2's. So you get minus pi by 6 less than equal to 3 theta less than equal to pi by 2. Now we can see that, pi by 2. Now we can see that 3 theta lies in the range. 3 theta also lies in the range of the sine inverse. So this expression is true. Okay. So we can write sine inverse sine 3 theta is equal to 3 theta because or since 3 theta belongs to the range of the sine inverse, that is minus pi by 2 to pi by 2. Okay, so now we have got 3 theta here. Okay, we got 3 theta here. So 3 theta. Now we have taken x is equal to sine theta and theta is equal to theta can be written as sine inverse. So we change this theta to sine inverse. Okay, applies. This can be written as sine 3 sine inverse x, which is the left hand side. Okay, so we have proved, which is equal to the LHS of the question, hence proved.